With Feature Engine, we can also implement the Recursive Feature Addition hybrid method, where we build a model to determine the feature importance. Then we start adding one feature to the model, starting from the most important to the least important, and we will retain the feature if the increase in model performance is bigger than a threshold. We did this manually, and here we are going to see how to do it with Feature Engine. We need to import the Recursive Feature Addition, which works for classification and regression. So for a classification scenario, I will just skip ahead to the implementation. We first need to create a classifier. In this case, I use gradient boosting classifier, but you can use any classifier that you want. And then we create an instance of the Recursive Feature Addition. When variables equals none, the class will examine all variables in the dataset, which for this dataset they are all numerical, so it's not a problem. We passed the model, we passed the metric that we want to evaluate, and the threshold. Recursive Feature Addition works with cross-validation, so we also indicate the cross-validation fault. With fit, the model is doing the Recursive Feature Addition process and selection, and after fit, we can find the performance of the model built on all the features, the feature importance derived from this original gradient boosting classifier, the performance drift after we added each one of the features in this plot, and then the number of features to drop, which is quite high. With transform, we remove the features from the dataset, and then we can build a final model and compare the ROCAUC, which is actually quite similar to the one that we obtained when we used all the features. For regression, the procedure is pretty much identical. We just need to create a regressor instead of a classifier, any regressor that you want. In this case, I'm using gradient boosted regressor. And when we set up the Recursive Feature Addition, we pass the regressor and then the metric that we want to evaluate, again with the threshold and the cross-validation fault. When we fit, the algorithm is training all these models and selecting the features. And then again, we can find the initial model performance, so the original R-square. When we use all the features, the feature importance derived from this original model, then the performance change when we add each one of these features to the dataset, the features that will be removed, we transform, we select the features, and then we can go ahead and build a model, and we see that the R-square is pretty similar to the one that we obtained when we used all the features. So go ahead and give Feature Engine a go and see if this is a method that you find useful when you work with your own datasets. That is all for this video.